Come in, this is my home and I'll show you around. So this is where the boiler used to be. We've had that removed. The loop's now been reconnected back together, so because it's a continuation of circuit. That's been insulated because we're in a non-heated room. Here's a small glance at my setup. I've got 13 kilowatts of solar battery, 3.6 kilowatt inverter. We use these fuse box subboards to power everything when it comes to the air source heat pumps. I'll take you out to the radiators. In 2018-19, we had these brand new designer radiators installed. They're quite expensive. They can be £300 or £400 each. As you can imagine, we've got quite a few of these, so we wanted to do everything we could to keep them. So as you'll see, they're connected on Microbore, and there's a fancy little controller there by Adia Thermal. That system has allowed us to reutilise these kinds of radiators without having to change any of the radiators in the house. And as you'll see over here, we've got the more stylish, taller radiators, so you can imagine we didn't actually want to change them. Take you through to the living room, and we've got another taller one there, and the more traditional horizontal one here. Everything is on 10mm Microbore, which can present its own challenge, but by using the Adia Thermal, that manages that circuit. It's self-balancing and self-commissioning. This is the Adia Thermal hub. So basically this piece of kit allows us to retain the possibility of retaining the original cylinder if it's in good condition. A lot of the original rads provided there within reasonable reason to where they need to be as a heat output. It also allows us to tackle things like Microbore and a few other things. In effect, it's an intelligent buffer or a brake. So it's got a hydraulic brake inside. The technical side of this system is it talks to all of its room thermostats and its room actuators. That information gets put back to the Adia Thermal hub. That then can determine what the need is for the house, and that then controls the heat pump thereafter, and then converts that energy and moves it more intelligently around the house. So in effect, it's a very clever distribution system that allows you to it self-calibrates and self-commissions and learns the house over time. So the Adia Thermal hub basically benefits installers by you don't have to now commission, it self-commissions, and it genuinely does it. We did that with this one. It overcomes other obstacles which engineers may have to then investigate, upgrading pipes and replacing them within reason. It also then allows you to have a lot more control over each room, which a lot of customers are looking for that. So it's an all-round solution for installer and for customer end user. Right, let's take a look in the loft. What we've got up here is basically we took the pipe up through the floor, so I've just got to put this board back now, all the job's finished. We took the pipe up from the floor, from underneath the cupboard, up along here. This is all insulated in 25mm closed cell insulation. It goes down through to the eave and then through the soffit board, and just before it exits the building, the primary pro is pushed through about this far. That gives it all the weather protection as well as the insulation, so the whole system is sealed, so it doesn't do any heat loss in this area. Right, let's go out to the actual heat pump, shall we? I'll show you that end. So, as you can see, we've had the gas meter removed. That only took about a week and a half, 2 weeks, I think, to call the gas provider and have that removed, so we don't no longer pay a standing rent for that. On this side, so the electrics to the heat pump from the main house, because the electric panel's on this side of the house, comes straight through the wall, up into the loft, all the way across the loft, comes back down the other side of the building, and then that comes through to the heat pump, which I'll show you now. Nicely tucked in the corner out the way. And here you go. How's that? So, as you can see with the electrics as they come down the wall into the junction box, just so they can come into the main isolator and back out down to the heat pump. And then you can see the cable behind it is the communications cable. Other than being a bit dirty because it's very windy and cold here at the moment, as you can see, it's sitting in the gap nicely. It's got plenty of room to breathe. Anti-vibration mounts, nice soak away for the condense. Super quiet in this corner. This end of my neighbour's house is an actual garage, so they don't live in this end of the house. The same as my house, it's a built-in garage on the side of the house. So actually for them to hear this, it's got to go through the whole garage, through 2 sets of walls and a hallway. So I spoke to my neighbour, we're good for it to be here. No one can hear it. and it's actually running and it's dead silent. With this installation, because of where we are and the fact that we're up high on a hill and the fact that it's going to get a lot of weathering, so we've chosen Primary Pro insulation. This is very well sealed armoured insulation, which helps against weathering and wind. And so with the Adia Thermal hub, we're looking to use the Adia Thermal system in most of the residential installs we're going to do moving forward. We think the equipment is suitable for nearly every install that we'd be looking at.
So the motivation for finally getting a heat pump in our house was twofold. One, we've been installing these systems for quite a few years now, and seeing the results of other people benefiting from an even, comfortable and distributed heat across the house, and the talk of savings on bills. We were looking forward to doing this. We hung on for the Adia Thermal hub. And when it finally came out, we were one of the first to grab one and get this system installed, and we've been living with it for a while now, and it's very comfortable, and it's made a difference actually to our comfort and our lives, truly. How the system is performing in the house today, I'm genuinely quite impressed. We're getting high SCOPs of 4.1. I'm surprised at that with the Microbore, and the fact that we didn't change any of the radiators, so far it's very impressive. We install quite a few systems, and we're monitoring and measuring other homes. I would say this is quite keeping up with the top 5% so far. Obviously we've got a bit of time to go further, but at the moment every measure is looking like it's in the top 10, top 5. It's very impressive. Got a very unique microclimate here. Since we've installed the renewable heating and the heat pump, we have been a constant, stable temperature, regardless of external wind and temperature. So it's impressively held the temperature evenly, and it works very well. You shouldn't worry about the myth that gas boilers are cheaper to run than heat pumps. They're not. In our experience, we managed to get the heat pumps to run cheaper than the gas boilers, especially if they're installed and commissioned correctly. And to add to that, I haven't paid for any heating or hot water for the last 8 weeks because my solar has taken care of all of that as well. Nice. Good.